Alright everybody, this is triangular prisms, solving for the surface area of triangular prisms. These are very difficult. Let's go ahead and get started. Now, to solve this, for one thing, I'm asking for total surface area and lateral surface area. Once we get the total surface area, it's not very hard to get the lateral surface area. And if you work through the entire problem, you'll get both really easily. But this is the beast here. Okay, so fairly difficult. A lot of parts. What we need to do is make sure to do it patiently, and we need to have a lot of organization with these problems. The goal is always the same. Figure out the entire area of this shape right here, this surface net. So you figure out the area of all the individual shapes, and then you add them together. Now when you have it in a 3D figure like this, it's a little bit harder to comprehend. If you got something flat, well, you just need to do length times width, and then base times height divided by 2 for this here. This is a little more complicated. So what I suggest is, let's find the areas of the triangles first. The triangles are always going to be the same area. So once I solve the area for the triangles, for one triangle, I can just multiply it by 2. All right. So we have this. I'm actually going to label this. I'm going to solve the areas for the triangles. And in any triangular prism, there's going to be 3 rectangles. How many rectangles are here? There's 1 here, 1. There's 2 here. And then the third one is in the back here. 1, 2, 3. So there's 3 rectangles. So I'm going to put the triangles here, and I'll put the rectangles here. And I'll do rectangle 1, R stands for rectangle, rectangle 2, and rectangle 3. Okay, nice and organized. Let's see, just raise this. Okay, so for the triangles, here's one of the triangle. The height here is the distance from the apex of the triangle to the base. It creates a 90-degree angle there. So this is the height, and this is the formula that I'm going to use. Base times height divided by 2 divided by 2. So the height, that's going to be 4. And the base of this triangle, well, it's not given here, but it is given over here. And I can just take this over, move it on over, which is 6. So the base is going to be 6. And now make sure that I divide it by 2. So 6 times 4 divided by 2. 6 times 4 is going to be 24. And then divided by 2 is equal to 12 centimeters squared. So this right here is the area of one triangle. Now I've got 2 equal triangles, just like in this prism here. I've got 2 equal triangles, even when I fold it up. They're 2 equal triangles. So we'll do 12, and then we're going to multiply it by 2, which gives me 24 centimeters squared. And this right here is the area of both triangles. Now one thing that you might notice is, Mr. Corbett, you divided by 2 and then you just had to multiply by 2 again. Well, yes, I did the whole process to hopefully show you that we're going to divide by 2 to get the area of one triangle, and multiply by 2 to get both. But if you'd like to go straight from here to here, you may, knowing that you're just going to multiply by 2 in the end. Okay, so we're halfway done. Now the rectangles, rectangle 1, we'll have it be the one that's closest to us, so it'll be this one right here. So it's 12 by 5. That's the rectangle. 12 by 5. I use the nice orange. 12 by 5. And that's equal to 60 centimeters squared. Now for rectangle, for rectangle 2, let's do the one in the back here. Okay, well this is also 5 by, well, it doesn't give me either of these lengths, but I know that this right here, I can just take this and move it straight across. So this is also by 12. So we'll use a nice pink. This was also 12 times 5. I recommend centimeters squared. That you actually do it like this, rectangle 1, 2, and 3. This was an isosceles triangle where both of these sides were equal. It's not always going to be like that. It could be a scaling triangle where all the sides are different. Okay, finally, we'll do the triangle on the bottom, which is this one right here. Okay, so this is 12 by, the width is 6. 12 by 6. And that's equal to 72 centimeters squared. Now I've done all the calculations, or most of the calculations. Very neat, it's very tidy even for a messy guy like myself. Now we just need to add all these up here, because these are the areas of the 3 rectangles. We want the area of all 3 rectangles. So 60 plus 60 is 120, plus 72 is 192 centimeters squared. And this is the area of all rectangles. And to figure out the total surface area, how many shapes were there? Well, there's 2 triangles, and we found that that was 24 centimeters squared. And the 3 rectangles was 192 centimeters squared. So now all we need to do is, of course, add them up. So I'm going to do it right here. 192 plus 24, 6, 1, 1, 216 centimeters squared. The total area, 1,016 centimeters squared. Now lateral surface area, we don't have to do a thing. Lateral surface area means, I'm going to write it up here in this corner, just for a refresher. Lateral surface area. It is the surface area without the bases. The surface area without bases. The bases in a triangular prism, in any prism, are the 2 equal sides. So it's these 2 triangles. These are the this is one base right here, and this is the second base right here. Lateral surface area, we are not going to contain, we're not going to include that. So we're just going to include what's in the middle. What's on the side. What's in between the 2 bases. This is what's lateral, the rectangles in a prism. So you only need to solve for the rectangles. And we've already done that, which is 192 centimeters squared. Is the piano blocking it? 192 centimeters squared. Okay, next problem. A lot of work for that one problem. Oh, it's frozen. I'm going to rinse this now.